In previous presentation of MT series, we demonstrated you excellent precision of MT device for positioning ionization chamber in water phantom for absolute dosimetry in brachytherapy. The goal of today's lecture is to show you another, more simple and practical decision for this calibration procedure with little less accuracy than previous scheme. This is so-called headpin device. For this design version, we use the same source holder as described in last presentations. It is so named curved catheter layout where radiation source pressed to the lower wall of the catheter when it's moving to its dwell position. Non-parallelity of the ionization chamber and catheter we see from shape of the electrometer current when source is stepping along catheter with 3 mm step. To correct parallelness, the holder has angular adjustment. In this case, we use smaller ionization chamber, 0.125 cubic centimeter, in order to reduce correction factor for chamber dimensions. In standard ionization chamber holder of TNMC water phantom was cutted narrow groove to fix ionization chamber in correct angular position. Headpin device was made of steel needle mantrel. It hangs up on catheter using a special wire device. All this build-up I am immersing into water tank, taking care about tightening of the screws. For measurement of the headpin device length, we use special assembly with adjustable plate. Reflection image of the device in the surface of this plate indicate how far the tip of the device from the contact with the surface at so-called calibration point. Water tank mounted on typical medical wheeled frame. So in this way, very easy slightly to move the frame, creating swinging of the headpin device for indication contact with ionization chamber surface. Now about result of measurements. For the length of the headpin device measuring tool, we have 39.54 mm. We name it as device constant. Mold probe catheter with diameter 1.8 mm. Iridium source inside 0.9 mm diameter. Catheter wall is 0.25 mm. Possible tilt of the source inside catheter gives us additional gap 0.1 mm. And finally we have distance from catheter upper surface to center of the source 1 mm. This ionization chamber much more smaller than pharma chamber, and the correction factor for the chamber dimensions is only 0.05 mm. If we add all these values, we will get distance from the center of the source to the center of the ionization chamber 42.02 mm. Energy dependence of semiflex chamber response is very similar to pharma chamber. As you remember, we found it for iridium energy by interpolation its beam quality factors. So we multiply electrometer readings with chamber calibration factor, beam quality, decay factor, and temperature pressure correction factors, and the result is 0.428 gray per minute. The treatment planning system Brachyvision version 10 give values for this distance 0.434 gray per minute. Difference measurement to treatment planning system value minus 1.4%. And if we take into account absolute calibration of iridium source measured by well chamber minus 1%, we have our final error minus 0.4%. is very acceptable result. Here is some conclusion and recommendation for using in quality assurance procedures. This presentation I would like to present as electronic poster in ESTRO 35 meeting in Turin this year. If you have question, please send me emails. Thank you for attention.